stored it. So this is absolute value equation. We have already looked at the first expression, that absolute value expressions, if you are solving the equations, this expression over here will keep some things positive. And here, when I have highlighted something in yellow already, this highlighted thing over here, this one, is gonna make part of the equation positive. It's not gonna be negative. But how to solve it? To solve these things, first step, look at the step number one. What is it saying over here? Step number one is telling you to isolate absolute value expressions. How to isolate it? In this given line, it's already isolated. What do I mean by isolated? Do you see anything being multiplied outside the absolute lines here? Anything being multiplied? Like I have it here, this green color A, it's a multiplication to the absolute expression. It's not there. Agree? Then I have a plus D also in my created equation. This plus D is not leaving the yellow expression isolated. So if I want to make an absolute expression isolated, I need to get rid of two things from here. And A and D both should be gone. Once these are gone, then my term will be isolated like this. How can I make them go? If it's an addition, subtract it on both sides. The same operations that you're always doing to solve any algebraic expression. D here is added, subtracted D on both sides. A here is being multiplied, divide with an A on both sides. That's how we'll do it, and then we will simplify it. You can keep these steps in your pocket. Come back to these same steps, how to solve it. I will now solve one of these questions for you. Which one do you want me to solve? Tell me. 4. Number 4? Okay. So number 4 here, let's try to solve this. What is it saying? First of all, which one is the absolute value expression here? Can you tell me? Which one here? I don't like it. Every single time when I try to zoom in, it happens. Okay, so this is the question number 4. What do you think is the absolute value expression here? Okay, good answer. This one, yellow highlighted. Is it not the absolute value expression? I will not include the 5 there. Let's remove the 5 because whatever is in the absolute lines, this one is the absolute value expression. And I need to isolate it. If I want to isolate it, what is in this expression overall extra that I need to get rid of? I need to get rid of this 4 first. First of all, I need to get rid of this 4. And then for sure, I need to get rid of this 5 also. Both of these need to go. Make sense? How can I get rid of this 4? How to remove it? Any idea? What should I do to get rid of this 4? Anyone? Subtract a 4 from both sides. Exactly. Let's do it. So minus 4 on left hand side, minus 4 on right hand side. We will subtract it. What will that give us? If I will write it down again in the next step, that's going to give me negative 5 times 3 by 4m plus a 12 absolute lines equals what? A 0 now. Is it difficult?
No.
No, easy. Good. So I will keep in mind that I'm still trying to isolate the yellow highlighted term. Is that isolated? No. What else do we need to get rid of? We need to get rid of this negative 5. What's happening here? Which operation is it there? Plus, minus, division, multiplication?
What? Wait, what?
This blue circle 5, what do you think? What is its operation with my yellow highlighted term? Is it added, multiplied, divided, or subtracted? It's multiplied. Whenever you will not see an operation, that's definitely a multiplication. So how can I get rid of that? If something's being multiplied?
Divide.
Divide. Good. So I will divide it with what? -5 on both sides. Where did I get the 0 from? I got this. Remember, we subtracted 4 on both sides. So 4 minus 4 is 0. Got it? So 4 minus 4 is a 0. Now, because I'm trying to get rid of that 5 also, the -5 over there. Now let's do the next step, and we do know at this step, obviously, my expression, the absolute value expression, is now isolated. Because this yellow term, it doesn't have any addition, it doesn't have any multiplication, division, or subtraction. So we have successfully isolated it. Make sense? That's what we mean by isolation. It's isolated. Good, it's done. But it's not solved yet. Now there is something new that you have not done that before. What to do here, in this part, we will split the equation or split the whole solution into two different parts. Left side, right side. Because whenever you have an absolute expression, remember, even if it's negative or positive, the absolute lines are telling me to keep it positive. But now I'm trying to solve it. So backwards operation, it can be negative, it can be positive. By the absolute lines, we made it or we forced it to be positive. While solving, I will have to think about both the possibility, and I will do every single time the same thing that I'm doing over here now. What am I doing? I'm trying to bring in here the same expression. How many times did I write that? 2 times. On the left side, on the right side. What I will do here, and you may hate me for that, I will put the same right hand side with a negative sign and with a positive sign. What did I do? I used two different sides of the split line. On one side, I put a negative, and then on the other side, I have added a positive sign. A negative and a positive. Is -0 different from +0? No, 0 is always same. But let's say if you have a 10 here, then what will you do? -10 here, +10 here. If you have a 4 here, -4 here, +4 here on the right hand side. That will give you two different solutions. But if it's a 0, it will definitely give you one solution. I don't need to solve the right hand side in this case, but remember, you told me to solve the question number 4, and it's there. But if you have something different, you will find two different values, and you will have two answers for the set for the m here. Now it's only 1. Now, how can I solve for m? I need the value of m. How will I do that? Again, isolate m. How will I get rid of this 12? Subtracting a 12 on both sides. Once that is done, this 3/4 here is being multiplied. I will divide it with the same thing or with this inverse of the fraction, and we are done. Let's do it together. So, first step, subtract a 12 from both sides. That will give you 3/4 m equals -12. 3/4 m equals -12. And then what will I do? I will multiply on both sides by the reverse of that fraction, which will definitely cross these out. 3/3 is a 1, 4/4 is a 1, and you're left with an m equals, the solution of the other side is -16. M equals -16 is my result in this case. Make sense? Is it difficult? Easy? No? Not easy? Should I give you an easy solution for this also? Any absolute value equation that you want to solve in an easy way, let me tell you an easy way on that. Use Desmos. How to use Desmos to find a solution for such equations? Let's try it now. Don't worry if you have not taken the notes yet, I will take you back to the same screen in a while. First, let me show you how can you find the solution for such an equation in Desmos. What was the equation? We had a 4 minus 5 times. I'm just typing in the equation over here. 4 minus 5 times 3 by 4m. I'm putting an m there. I can use an x instead of m because the same solution which works for x will be valid for m also. X and then plus a 12. I closed the line and I equated that to a 4. I equated that to a 4. Do you see something on the screen? Oh. Do you see something on the screen? No. Let me zoom it out. Do we have something on the screen now? No. Equation is not there. Let's see one more thing. If I will remove that equation from here completely in Desmos, here, this is gone. Do you see it now? Where is it? It's here. Equation is gone. So where is the function? Now keep it in mind, as soon as you will have your absolute function plotted, it will be gone if you will put it as an equation. Equation will not be looking like an absolute function plot. As soon as you will bring in here inequality, the plot will be gone and you will have only one point as a result. In this case, this is the negative 16 here, negative 16. If I will just remove it from there, keep in mind, where is this point? Here, negative 16. X is negative 16, the vertex point on that. Keep it in mind. This is going to be useful for you. Okay? This can help you to figure out what is the value of X that will become my solution in that case. Keep it in mind. Don't forget about that. Okay? If you will look at the expression, what was the expression that we tried to bring in here? A 4 was giving me a solution on this. Anyways, let me show you one more thing here. Your question number 1. Here, your question number 1, and I'm almost done. My steps that I wanted to share with you are almost done. You will do the same thing here. Plot it in Desmos and you will find a solution. Look at the question number 1. I'm going to bring that question number 1 over here in Desmos. So the same way, 2 by 3. 2 by 3. What will I do then? Absolute value of x. 2 by 3 times absolute value of x. Yeah, plus 4. Do you see something on the plot? The plot is there. And I told you, as soon as I will bring the equality sign, the plot will be gone. And that will completely change. Equals what? Equals a 10. How do you see it now? 2 lines only plotted here. One line is at 9 and the other line is at negative 9. Agree? One line is at 9 and the other line is at negative 9. If you will try to solve that question number 1, trust me, the 2 solutions that you will find will be a negative 9 and a 9. You can draw it now. You can try it now in a while. This process, the Desmos, keep listening. This process, Desmos, is useful in if you have equations, and this is also useful if we have inequality. These are my last words for this session. Okay, look at this. What I will do, I will change this equality to an inequality. Last words, inequality. What happened? It's highlighted, it's shaded. Now, this is telling me all the possible values of x for which this expression will remain less than 10. That's how we think about the inequalities in absolute value expressions. Now, last words I told you. If I will put here an equality sign, did you notice the change?
No.
I will do it again. Gone?
Oh, that.
You see, when it's equal, that line is changing. When it's equal, the line is not dotted, it's a solid line. That means that line is part of the solution. Okay? So whatever question you're trying to solve, if your solution, like if you're looking at Desmos, the solution will be the points where the curve or the line will intersect the x-axis. Got it? That's finished. That's what we wanted to learn about this topic. I will take you back here. We have discussed the question number 4. We solved it here. Question number 1, I did solve it graphically. Solving graphically means I showed it to you. How can you solve this question number 1 in Desmos? But you can definitely follow these steps also. Absolutely. As isolating the terms, find a solution. Okay, we done? There is no solution for question number 3. Here, you know why there is no solution for question number 3? Because whenever you will face this case, which case? Whenever you will face this case that you're trying to isolate it, you're trying to isolate the absolute value expression and you end up with a negative sign on the expression. How? I will do it for you. Where is the absolute value expression here? This expression, k minus 1, is the absolute value expression. And as per our discussion, we thought that we want to definitely get rid of negative 3. That's how we will isolate it. If I will try to do that, dividing on both sides with a negative 3, what will I get? Absolute value of k minus 1 equals a negative 4. And that is a problem. You know the problem now, Alexander? Alexander? What I was sharing, last thing, and then I'm done, I will stop the recording also here. Is it possible to have absolute value negative? It's not possible. So mathematically, this expression is not true. While solving this, whenever you will face a case where your absolute isolated expression is equal to a negative sign, no solution. But you will do over here, you will simply write no solution and we are done. Okay? You will write here no solution and we are done.